Hello students! In this lesson, we will mainly discuss about hydrocarbons. Specifically, we will tackle about the three main classifications of hydrocarbons and their respective characteristics so that we will be able to identify them. So please stay tuned towards the end of this lesson as I'll be revealing after the answer to our pretest. So, based on these chemical formulas, can you identify what type of hydrocarbon are they? By definition, hydrocarbons are organic molecules that is mainly composed of hydrogen and carbon atoms. So from the name itself, hydrocarbon, it's hydrogen and carbon are its main components. And they have three main classifications, namely the alkane, the alkene, and the alkyne. So as you can observe, we just simply replaced one letter within the entire name. That is the letter A, letter E, and letter Y. So, let's get to know more our hydrocarbons. First, let's have our first classification of hydrocarbon, which is our alkane. So, alkane is a saturated hydrocarbon which contains only a single bond. And among all of these classification of hydrocarbon, alkane is the most stable one. Now, alkane has a suffix of ane or ane towards the end of its name. So that's one way to identify if a specific molecule is an alkane or not. Now, to further identify an alkane, we have this formula Cn H2n plus 2, wherein N represents the number of carbon atoms. Now, we just have to simply substitute letter N with the number of carbon to see if that specific molecule is an alkane or not. We have further examples here for alkane, for we have methane, ethane, propane, and butane. So as you can see, all of these hydrocarbons ends with an ane, so automatically that identifies as an alkane. So here are their respective structural formula. Next, we have our second classification of hydrocarbon, which is our alkene. So alkene is an unsaturated hydrocarbon and it contains a double bond. It ends with the suffix of "-ine", so as you can see, it's an alkene. Now, this alkene is called unsaturated because it's not saturated with hydrogen atoms that should surround the carbon atoms that an alkene has. So instead of saturation of hydrogen atoms, it contains a double bond instead. Now, our alkene have the specific formula of CnH2n, wherein N represents the number of carbon atoms, and in order to identify if that specific chemical formula of a molecule is an alkene, then we just have to substitute the letter N with the number of carbon atoms. So we have here an example of alkenes, which is our ethene, our propene, and our butane. So basically, as you can see, we just substituted it with the suffix of E and E. And these are the specific structural formula for our hydrocarbon examples of ethene and the other one that is a butene. So as you can see, they have double bonds connected between carbon to carbon. Now for the third and last classification, main classification of hydrocarbon, let's have our alkyne. So alkyne is another unsaturated hydrocarbon and contains a triple bond, and it has a suffix of Y-N-E or ine. So basically, this is another unsaturated hydrocarbon because instead of filling the carbon atoms with hydrogen atoms, it fills up itself with a triple bond within carbon-to-carbon triple bonds. Alkynes have a formula of CnH2n minus 2, and you just have to substitute the number of carbon atoms in that letter N in order to see if we can have an alkyne out of the chemical formula that we have. And examples of our alkyne includes ethine, propyne, and butane. So these are the same examples that we have earlier, but we just simply substituted the suffixes of Y and E instead of the ENE and ANE. And these are the structural formula for our examples of our alkynes. So as you can see, they have three carbon-to-carbon bonds, triple bonds of carbon-to-carbon, and the same thing can be said with our propyne. So thank you students for staying up until the end of this lesson, and now we have the answers to our pretest earlier, and you guessed it right. Number 1 is alkane, number 2 is alkene, and the third one is alkyne. So we just simply did the math and substituted the number of carbon on the formula that we have in order to identify if this specific chemical formulas that we have belongs to an alkene, alkene, or alkyne. Alright, so thank you for watching, and I have another gift for you. I will put down on the description down below the link to the PowerPoint presentation that I used for this discussion so that you can study on your own pace at your home. And stay tuned for the next video as I'll be discussing about naming of these hydrocarbons and how the technicalities and how do we name them based on IUPAC standard. Alright, thank you and see you in the next one.